yes, this has some good exponent rules. What to do with square roots and cube roots and fourth roots? Do you remember that a radical can be changed to a fractional exponent? So a cube root is an exponent of 1/3. A square root is an exponent of a half. Did you remember that from grade 11? No. Perfect. Right? So if I have a square root of x, it's the same as x to the half. If I have a fifth root of x, it's x to the fifth. If I would have a cube root of x to the 4, that would be like an x to the 4/3. Next, I look at my numbers. Are 2 and 8, can they be written as the same base? Yes. I could rewrite my 8 as 2 cubed. So if my 8 is 2 cubed, and this is 2 to the 1/3, what was your exponent law for multiplying if you had the same bases? Right? If I give you nicer numbers, like if I had 3 squared times 3 to the 5, this is equal to 3 to the 7. So when you multiply the same base with different exponents, you added the exponents. We're going to have to add here, but this time we're adding fractions. How do you add fractions? Common denominator. Can you see that 3 I can make as 9/3 plus 1/3? So I finally get to this point where I have the same base on both sides. And if the bases are the same, then I know that these exponents have to be the same. So x has to equal 10/3. What exponent rules from grade 9, 10, and 11 did we remember here? We had to remember how to change radicals to exponents. We had to remember our exponent law for multiplying. If the bases are the same, then you add the exponents. So take your time, change one thing at a time. The 125 is 125 to the half. And then this is 2x plus 1 equals, I don't even need brackets there. Just do it like this. And the cube root would be 625 to the 1/3. So I just did one thing. First of all, I just changed my radicals to exponents. Next, I see 125 and I see 625. Are they on the same column? They're powers of 5. So I take 125, put it in brackets, change it to 5 cubed. That means I'd still have the half there, and I'd still have these brackets with the 2x plus 1. The 625, that's 5 to the 4. And I'd still have the 1/3. Here I have a power to a power to a power. We're going to have to multiply all of those through. So this will be 3 times a half, 3 halves. 3 halves times this, I'm going to get 5 to the 3x, 3 halves times 1 plus 3 halves. And on this side, I'm going to get 5 to the 4/3. And now we've got both sides with a base of 5. So our exponents have to be the same. 3x plus 3 halves has to equal 4/3. And now you just have to solve for x. You have fractions, so maybe you want to move the 3 halves to the other side. You would need a common denominator, so I'm going to make the 4/3 8/6. And I'm going to minus 9/6, which will give me negative 1/6. So 3x would equal negative 1/6. Divide by 3, which is the same as multiplying by 1/3. And I get x is negative 1/18. Questions for practice on this one are 9 and 10. Really practicing our exponent laws and figuring out how they work together. These are all the non-calculator ones. Eventually, we're going to run into, right? Someone's going to ask, well, what happens if I can't write the bases the same? What happens if I have 7x equals 30? None of those numbers are on my powers chart. Well, the 7 is, but in the 7 column, there's no 30. How do I do this? There is a number that works. We could even see how close we could get. I think it's 1.2. Ooh, not even close. So I try a bigger number. Obviously, it's not 2 because 7 squared is 49. So maybe it's 1.5. Or maybe it's 1.8. Oh, that's too much. How long is this going to take us to get it? Oh, not too long. Look at, I'm getting so close. But this is actually addicting. Don't do this at home. You might just be on your calculator all night. Oh, I'll try another number. Okay. Can you see yourself getting addicted to this thing? Or am I just crazy? Don't answer. Oh! We've got like 30.00. And I could keep going, and I could keep getting closer and closer and closer. And eventually, I could figure out what that number would be. $1.747869697. That would be, look at that. If I do 7 to that exponent, you get 30 exactly.
We have to run. Are we gonna run